Alright, so here we go. We're going to throw a wrench into everything because it can't all be easy, right? This is a convex mirror. So notice the focal points on the other side. So when we measure the distance, we're going to measure the distance from the middle of the circle to the front edge. Measure it to the front edge of the mirror, because that's like out in the real world. So that is 2.7 centimeters. So we're going to go 2.7 centimeters on the other side. Remember that your center of curvature and your focal point are on the same side of the mirror. C and F are on the same side of the mirror. All right. So from the top of the object, we're going to go in and out through C. Okay, so we're going to line the top of the object up with C. And we're going to go in and out through C. Now, why did I stop at the mirror? Because once the light hits the mirror, it's going to bounce back. Okay? That's hard to make yourself do. Our second ray goes in parallel. And then it's going to go out through the focal point. So we're going to line this spot up here with our focal point, and we're going to go out this way. Okay? So it's going to go out through the focal point. Uh-oh, we have that same problem we had before, where our two out rays aren't going to meet on this side. So when they don't meet up on this side, that means you need to make them go dotted on this side. So we're going to bring this guy back. And we're going to bring the in and out through C, dotted behind. And then it's going to meet up about here. Okay, this is a hard one to do. This third one. This is the one everybody messes up. You're going to go in through the focal point. But remember how when we went in and out through C, we stopped when we hit the mirror? We're going to do that same thing. Go in through the focal point, stop when you hit the mirror. Do not continue to the focal point. Stop when you hit the mirror. Because once that light hits the mirror, then it's going to bounce out. And it's going to bounce out parallel. So it's going to bounce out that way. And then we go and see it's meeting up with the other guys here. Now we have our last one in through the vertex. Your vertex is in the same spot here, still where the curve changes right on the principal axis. So you're still going to line up the top of your object with your vertex. Top of the object with the vertex. Start further back so that you can measure this. And then line up your protractor. Line up the little T on your protractor and the 90 degrees. So this one is like 13 degrees. So we're going to mark 13 degrees on the other side. And we're going to go from the vertex to where we made our mark. This is a little cleaner. Out 13 degrees. And then again, bring this guy back. Dot it. And there you go. There's your image right there. And so this is upright. It is virtual because it's in the mirror and because it's upright. And it is reduced because if we look at our little arrow here, it is much smaller than that arrow there. And it is much closer to the mirror. That's how we know.